Okay, so here like the trigger pin and echo pin I'm connecting. Okay, then so this is a sensor. We completed with the trigger pin and echo pin. Now we are going with the concept of this particular sensor, and this sensor can't be directly connected, guys. Actually, we get MQ3 module. So if you type a MQ3 module, so we are going to get like this gas sensor directly. So like these modules are available, and so it has already like a supporting circuit is already available on the board itself, on board. But here we are not using the, we don't have an entire module, we have only this particular sensor. Okay, since we have only this sensor, see, if you consider this ultrasonic sensor, guys, ultrasonic sensor also have some, see, ultrasonic sensor also have some background circuit. You can observe this particular part. See here, so here it has some background circuit, but luckily what we have is they already provided a direct ultrasonic sensor which has already all the supporting equipments, the background circuit, everything is ready. Whereas this one they gave only the bare sensor, that means the previous way what I showed you. So due to that reason we have to use this one rather than use it, like we have to rig up the circuit. And circuit is very simple. If you type MQ to gas sensor Tinkercad, okay, if you just type like this, so it will show you the base circuit diagram. Yeah, this you can refer. Anything is okay, but it is better if you refer any one standard circuit. Yeah, as per this circuit you can observe here. Yeah, you can observe here. So this is a gas sensor. So 1, 2, 3, all three things has to be connected to 5 volts. Okay, and the middle pin supposed to be connected to ground. The first pin is a so third pin is a output, that is analog output, and the first pin has to be connected through a resistor to the ground. Okay, so let's design the same thing. So first thing is all three supposed to be connected to VCC. Guys, here along with the application, you should also observe how exactly methodology I am following in order to build a new product. Okay, so here the internship is not only about teaching you the applications, it's about the methodology. So you should observe the methodology and learn the methodology for product development. What is the methodology we are following for product development? Okay, this is our 5 volts, and the first one is ground. So anyhow, we have one ground here in the and so yeah, first one should be connected through the resistor, second one directly to the ground. This is second one supposed to be connected to ground. First one has to be connected through the resistor. Okay, and last one to the output. So let me select A naught for this work. Okay, so then followed by a temperature sensor. Temperature sensor is directly V out, that is VCC ground we have to supply, and we have to supply the we are going to get the temperature signal that we have to use for the further purpose. So this is ground and this is power. Yes. So this is what the entire circuit you have to finish. So you can observe here. So we are using a different pins. So analog pins for few circuits, digital pin for few circuits. We are not using any PWM pins because our application is purely having only digital input and digital outputs only, not like a, yeah, sorry, PWM we are using for servo motor. PWM we are using for servo motor. Okay. So this is one application which can control the smart agriculture application. Yes, complete the remaining part of the circuit. Just give me some time. I like a WhatsApp web is connecting. I'll send the circuit diagram which I downloaded. Yes. So use this screen. I'll send the photo of this one in the WhatsApp group. So I know a little bit complex for your level. Maybe some of you may feel it complex. Yeah, I sent it in a WhatsApp group. So please follow that and complete the circuit. Right? Yeah, see guys, this circuit, even though we completed everything, still it won't work. The reason behind that one is, see, if you observe this entire part, we powered up by using this battery and this regulator circuit. Whereas this particular Arduino board is there, right? This is getting powered up by this particular USB. Okay. So there is a concept called as a common ground. Okay, what is a common ground is very simple. In case of robotics, in case of high power application, we use this concept. So in case of high power application or robotics, what happens? So whenever we are going to use a common, like the ground which is having, like whenever we in the different power sources, power supplies, like uh, if I want to send the signal for the equipments which are getting powered up by the one power source from the board which is powered up by the another power source, then we have to use a common grounding. Okay, so now if I want to send the signal from here to here, so we supposed to use this particular concept called as a common grounding. Okay, so whenever we connect both the grounds in common, then only it is going to work. Okay, so now if I start simulating, nothing happens here because no power supply, only this particular LED will be blinking because it has a, sorry, it is even that is not there because we already removed the code. Okay, everyone up to this stage understood? Yes. Hello. Am I audible? Am I audible? Okay. See guys, this is this is digital. Sorry, this is analog. This is analog, and we have two analog signals. Along with that one more we have analog, that is gas sensor. So three analog signals are there. Analog input. Okay, and these two are digital. In that one is the input, one is the output. Trigger is the output, whereas echo is the input. And we have one PIR, that is a digital, and we have transistor, that is a buzzer, that is digital, and we have servo motor, that is digital. We have a relay, the first one, that is a digital output. This is also digital output, this is also digital output. Okay, now our requirement is, first we have to start giving the naming for our pins as defined. So we have to give a naming for our pins. Trigger pin, and echo pin. Okay, then seventh pin, that is PIR. 7 as defined. So it is all about giving the names to the pins, guys. So this is the first one, as we know, this is for water pump. Six as defined. Sorry, sixth is buzzer, not water pump, buzzer. I got confused with this transistor. And next one is PWM signal, that is a gate servo. Gate servo as defined. Next is water pump. Four as defined. Spray pump. 3 as defined. Exist fan. 2. Okay, all these things. Yeah, gas sensor. Oh, we missed a gas sensor. Analog pin not yet declared. As defined. Gas sensor, that is A0. as defined. Temperature sensor. As defined. Soil moisture. Pin mode. Yeah, now we have to start declaring the mode of the pins. That is by using the keyword called as pin mode. Pin mode, trigger, output. See, what you have to learn one more thing in this one is very simple, guys. You have to define, you have to figure out how exactly to make a pin. See, this is common in all the C programming based programming. Like if you go for the any C programming based microcontroller. So in this one, naming the pins is like this only by using the hash define. This is called as a macro. Okay. So by using the macros, we are going to define the pin numbers. If you are going for we have one more method by using the variable also we can declare if trigger equal to 13, int trigger equal to 13. By using the variable also we can declare it. But here concern is whether we use a variable, whether we use a define. It's all about giving the name to that particular pin. First thing. Second thing is why I'm not using the trigger variable type of giving the names instead of I'm going for the definition is this is not consuming the time space. This is a runtime allotment, whereas this is before that during the compile time only it will allocate the memory. Okay, so this is a compile time memory allocation, this is a runtime memory allocation. So this is not going to assign the memory huge amount of memory will not be consumed. Of course, for every instruction whatever you're going to write, there is a code memory allocated for that, whereas this expects the data memory. This is consuming data memory, whereas this is consuming code memory. Okay, this is consuming code memory. Okay, only instruction memory, which is a very less. Whether you save 100 or whether you save the high number, still it is just like a same amount of memory will be consumed. When you go for this, based on the data you are entering, it is going to consume a different memories. That means memory consumption. Clear? That's the reason you should not declare anything in a until unless you have a requirement of variable declaration for storing something, not for defining. I'm talking about storing something. Then you have to go for variable declaration. If you want to just give the renaming for any of the pins, then you have to use a hash define. Understood? This is common in all the programming language. C, C++, Java, Python, any programming language you use, this will be common. Okay. Next thing is defining the mode of the pin. So here we are using a keyword called as a pin mode. Okay. So when we go for a like a Python example, Python based Raspberry Pi. See, in this particular point only you should understand how you have to develop the program using the different language. So any microcontroller, any microprocessor you take, first you have to understand how to read the input. So in the input there are three types, as I already mentioned you: analog, digital, serial. The basic types: analog, digital, serial. Input, how to read analog input, how to read a digital input, how to read a serial input. Same thing, output, analog, digital, serial. 3 types. Clear? So like this, input and output, we have a three types of data. Understood? Next thing is, you have to understand instructions to are syntax for reading, a syntax for defining any pin, syntax for defining GPIO pin for digital input, or output, analog, input slash output, serial input slash output, digital input for output, analog input for output, serial input or output. These 3 things we have to declare. Okay, these 3 things are there: digital input or output, analog input or output, serial input or output. Okay, so these 3 things, what we are supposed to do is, we have to go for the concept of declaring, how to declare it as an input or output, serial input or output. Actually, serial input or output is nothing but a UART communication. This is nothing but method to initialize serial communication. Okay, syntax for defining the GPIO pin for digital input or output, analog input or output, or serial input or output. So method to initialize the serial communication. So these are all the things you have to find out in all the any microcontroller you take. You take a PIC controller, you take a Raspberry Pi, Pico, or ESP32. Anything you take, you have to identify these 3 factors. Okay. After that one, same concept. Reading method, syntax for reading or writing GPIO, reading or writing data from GPIO pin, digital input or output, analog input or output, serial input or output. These are all the method for reading the data from GPIO pin. Okay, so this is for defining, this is for reading. So these things you have to understand in all the any microcontroller you take, you have to learn these things. Again, this one, again in the communication we have method to initialize SPI by identifying the SPI pins. SPI pins. Again in SPI pins, guys, we have a physical dedicated SPI pins. but this will become too depth for you. So later point I'll try to cover this. It will be too deep in as embedded system, so you may not feel comfortable with that data now itself. Okay. So now in this particular Arduino based controller like a ESP32, Raspberry Pi, ESP32 and many controllers like ESP8266, Arduino, all the family like a Nano, Uno, Mini, Micro, Mega. Like this, we have a varieties of Arduino supported boards are there, AVR supported boards. So you can use this particular syntax language for that. Okay, so here pin mode for making it as an output to define the pin mode syntax is like this: pin mode followed by targeted pin followed by mode of the pin. Pin mode is a keyword followed by targeted pin followed by mode of the pin. Mode of pin. Pin mode, targeted pin followed by mode of the pin. Okay, same way we have echo input, trigger echo, as well as because echo is the input pin, trigger is the output pin. So we have PIR, that is the input pin. Buzzer is output pin. Gate servo. Yeah, see this gate servo, we can't directly use it like a input or output because it is an additional library. So for this it is not like a regular pin, guys. It is a PWM pin, and we have one library called as hash define, sorry, not hash define, hash include hash include servo.h. This is a one more point you have to understand in any microcontroller. Syntax for defining the pin is okay. Then syntax for including the library, or include or import, anything you can mention. Importing library into program. Then along with that, syntax for importing the library into program and installing the library. Syntax for installing the library. And see guys, this is not something like unique information. This information, this syntax, everything you will get it in the YouTube also. Sorry, in the Google, YouTube, everywhere you can get it. Any microcontroller you take, how to install the library in so and so microcontroller, it will show you the details. How to install how to import the so and so things in the program library, it will show you exactly. But you should analyze these things. This is the minimum requirement. Okay. Hope I am audible to all of you, right? Yeah. So then followed by servo motor. For servo motor, we won't go with the defining the mode. Servo gate servo. So what I like a gate servo obj object. So what is the meaning of this one is very simple. I am creating a object. Actually it is a C++ concept. So it may be deep for you, like a deep concept for you people. Actually I am creating a one particular object of the servo motor. I am creating the object of the servo motor. So for that object I am going to attach the pin here. There is a inbuilt key, inbuilt function called as servo dot attach. Then water pump, it is output. Spray pump is a digital output. Exhaust fan is a digital output. Then gas sensor is a input. Temperature sensor is a input. Soil moisture sensor is a input. Yes, everyone understood till this point? Okay. See guys, for digital, there is a requirement of defining input or output actually for digital pins. Whereas for analog, there is no requirement. All three lines are optional because whatever pins you are having in this microcontroller, by default, all these things are analog input pins only. By default, it is a analog input pins. That's the reason we don't have a requirement of defining it separately. Getting? Okay, so just a minute. I was SMBIT. Just a minute. There was a one like I did one particular Excel sheet. In that Excel sheet, we had the information. Okay. Otherwise, let me create a new one. WPS. So I'll give a small assignment to you people today. So assignment is, it is not something like a practicing some circuits or something like that. So I want you to fill up this Excel sheet which has a few things. Okay. So the Excel sheet requirement is like this. Okay. So what I want is I want you to give the information. This is serial number, microcontroller name, IDE, that means software name, syntax, syntax for importing library, syntax for like importing the library, installing library, then followed by declaring, sorry, initializing GPIO pins, initializing GPIO pins. So for this, we need a 3 columns. For input, for digital input, for digital output, for analog input, for analog output, okay, and then you have to either you can take it from chat GPT or anywhere, I don't mind, but just fill this things for UART, for SPI, for I2C. Okay, these things. Then okay, same way after initializing, you have to also figure out. Say guys, so one, if you want to become a good at embedded system, if you are filling this, doing the work on this and getting the find result, so it will be really good for you to work with the, like whenever you want to go with a new microcontroller, you just fill up this sheet, so it will be easy. Same way how you are initializing, we have a concept of reading. Syntax for reading. So reading will happen only with the digital input from digital pin from analog pin from UART pins from SPI pins from I2C pins. This is for reading. Writing. Same way how you are using digital from digital output. because writing can happen only with the output. Initializing pin, reading and writing. Okay, so these things. So now you have to select a proper microcontroller. First you have to give the microcontroller name. Okay, so I'll show you for the like Arduino, ESP32, all the things. Arduino boards. It has many boards. You can find out the Arduino IDE. Importing the library by using hash include library name. Okay, then installing. Okay, for installing what like for installing either by library window or by downloading offline and installing manually. And see guys, now if you would like to give any kind of object object for this, you can select a file object. So you can mention like this. So whenever they click on this, it is going to take them to the this particular file, but it should be in the same folder. If you want to give any kind of screenshot, otherwise it will be really great if you can give a screenshot of the that particular picture. For digital input syntax, so pin mode, targeted pin, comma input. Again there are two types, only input is there. Same way we have a one more concept called as input underscore pull up. Same way, but for output we don't have guys. Pin mode, output. Okay, same way for analog input, not applicable, no need to declare anything as an analog input. For analog output also not applicable. Okay, for UART, serial dot begin. This is to start the serial communication. Same way for software serial, okay, this serial communication I'll let you know once we are using it, because remaining all the stuff will be complex at this moment. As of now we are using digital read and write, analog read and write, so we can work on this. Okay, same way for reading the values from these pins. If you want to read the values, digital read targeted pin comma, yeah, targeted pin, that's it, reading. And this is uh, holding variable. In which variable you would like to hold it, the value, that you can use it. Okay, that is for digital pin. Same way for analog pin, instead of digital write, it is an analog write. Analog read. Okay, here estimated values, it is better if you write that estimated values also, but it will change from controller to controller. If it is a 8-bit controller, yeah, like that we can mention estimated value 0 or 1, because it is a digital read. Analog read, estimated val 0 to 2 power of bit number. It means if it is a 8-bit, 2 power 8. If it is a 2 power 8 minus 1. Okay, example, if it is a 8-bit, example 8-bit means 0 to 255. Clear? 10-bit means 0 to 250, 0 to 1023, like that. So like this, step by step it is. Okay, so this is for analog read, analog pin. Same way for UART and SP and I2C, I'll let you know later. It is called as a serial read. Serial dot read is there. Okay, same way we have a serial dot read string. Okay, this I'll let you know later. For writing the digital value, so digital dot write targeted pin comma value. Targeted pin comma value. Digital, so for analog, right, analog write targeted pin comma value. Okay, all these things for Arduino board. So now what I want from your side is for Raspberry Pi. What is the method for STM32, for PIC controller? Okay, and for it's just a, if you do a chat GPT, you'll get all the things. MSP 430. Okay, just give this document to me. I'll send it in a WhatsApp group later. Understood? Hello. Okay. So now, as we already did a couple of the coding here, we did a reading, writing, everything, and few things are straight away we can read the values, whereas few things we have to read the values by giving some delay and everything. So let me go with the concept called as a first. I will go with the concept called as the first pin is, yeah. So this is just a digital write. Okay, because it is the output pin. So now let me consider if I want to make it like a high, if I want to turn on that, I'm using NPN transistor. Based on the type of the transistor you are using, you have to check when it will turn on. Okay, so in the introduction session only, I think I would have already informed you, there is a concept called as active high and active low. Active high and active low. So this active high and active low, it is going to it is going to give a sensible meaning. In case of sensors, active high means it is giving the high signal on activation. Active high means, in case of actuator, active high means it will activate after giving the high signal. Okay, I once again please listen properly. In case of sensor, active high means it is going to give the high signal on activation, on sensing. In case of active low means, sorry, in case of actuator, active high means it will activate after giving the high signal. Same way, we have a concept called as a sensor is over, actuator is over, active low. It will activate, it will give the low signal on activation in the sensor case. In case of actuator, it will activate after giving the low signal. That is active low actuator. See now, I am using a NPN transistor. As you people know, NPN transistor is having a collector, base and emitter. And as the name indicates, NPN, negative, positive, negative, like that you can consider. Actually, NPN abbreviation is different, but I am giving NPN negative, positive, negative. You can understand in that way. So NPN, what happens whenever the positive P, that means whenever you give the high signal to the base, whatever data is present in the emitter, that will be passed to the collector. That is how NPN transistor is going to switch. Okay, so whenever you give the low signal, whenever you give the high signal to the base, the data which is present in the emitter, that will be reaching the collector. Here NPN transistor is going to work in that way. So now what's happening, I am giving the, I would like to turn on this particular motor. So to turn on that particular motor, since I am using the NPN transistor, I am supposed to give the high signal. If I am using the PNP transistor, I am supposed to give the low signal. But whenever using the PNP transistor, instead of switching the negative part of the signal, sorry, power supply, negative part of the power supply, we are going to switch the positive part of the power supply in case of PNP. In case of NPN, negative part. In case of PNP, positive part. That is clear. Okay. And NPN and PNP in that case. Clear? So next thing is, so first program that I'm going to do is digital write. Yeah, one more thing I forgot in this syntax. Yeah, digital write. This is exist fan. Yeah, exist fan, comma I. Digital write exist fan, comma I. Delay of 1000. Okay, what is the meaning of delay of 1000 is 1000 milliseconds. It is going to make the digital pin. It is going to keep the same status for the digital pin. That is what the meaning of delay. Indirectly, delay is going to pause the program. Delay is going to pause the program. Same way, we can copy paste this. We can make it low. Okay, so this is the syntax for making the digital rate, activating the actuator and shutting down the actuator. So if I start simulating, we can observe 1 second it will turn on, 1 second it will turn on, 1 second it will turn on, 1 second it will turn on. Same thing you can observe in this particular relay also, symbol. See, according to the transistor, according to the signal pin, status of the pin, transistor is switching. According to the transistor, relay is switching. According to the relay, the final load is switching. Okay, so this is the concept of writing the high value or low value in case of digital signal, digital right and low, right and high and low. Yeah, I was referring something, right? I was mentioning something before this. So you should also like give a syntax for introducing the delay in control that specific microcontroller. Introducing the delay. So that will come under here. Yeah, like right side. In like inserting. Sorry, generating delay. Generating delay. So here I will mention delay micro delay in milliseconds. So whatever number you mention here, that will be considered as a milliseconds, 1000 milliseconds, 100 milliseconds, like that. Okay, so this is how you can generate the delay in the Arduino program. Okay, like this, any microcontroller you take, guys, in this way you have to understand. Simply going with a ready-made program and by hitting all the syntax of the all the parts of the program will not work out. Whatever I'm teaching is generalized microcontroller analysis technique. Generalized technique it is. Okay. So this is for reading, writing the, making a signal high or low, activating high or low according to that. So now as per our particular relay, so the buzzer, transistor, all the three motors, it is going to trigger in the same way. So talking about the servo motor will not be triggered like this directly. for servo motor guys, you have to use already you used gate object dot attach gate servo. Here you are using a one word called as right 90. What this will do, it will rotate the servo motor to 90 degree. Okay, so here you can also have a one more concept called as operating servo motor, because these the differs from the regular concept. That's the reason I'm just servo object dot attach dedicated pin servo object dot write dedicated angle. Dedicated pin and dedicated angle. Okay, so this is for servo motor. So what we supposed to do, if you observe the servo motor now, when you write like this, start simulation, see you can observe servo motor is rotating 90 degree, it is rotating, and since it is a like simulation guys, it is taking some time based on the internet speed, but when you go for the real servo motor, it will rotate quickly, within 2 seconds it will reach that location. Okay, so this is the servo motor. Now let me consider, I'd like to make it 180 degree forward backward. So actually we need this particular technique here. So what I'll do, void, I'm going to create a sub function. Of course guys, so C programming basics are required for embedded system design. So if you don't know the C programming, it is quite challenging for us to cover all the C basics as well as embedded C. After this training program, if you're interested for the language learning, you can let me know. I can conduct a course for that, completely like this zero level of like a placement oriented C programming, placement oriented Python programming. We have a course that you can plan. So void open gate. Okay, so if I mention the open gate, what I want is, I want servo motor to open the gate for like it is going to rotate a 90 degree, delay around 5 seconds. I want it to be in the same position, then it has to come back to 0 degree. Okay, based on my condition, I'm going to call this. Based on my requirement, I'm going to call this. Like this, 5 seconds it will be in the same status. Of course 5 seconds here is, it is a long duration only. Yeah, 5 seconds will become too much. I'll make it like a, yeah, one more thing is, since I called one time and it is repeatedly calling, so it will be always the same status. Now you observe, Yeah, now you are able to observe, right? It is opening and closing, because only that program we written. So like this, even when you go for a hardware also, one by one step you have to complete. Okay. Then we have a concept of analog read. And see guys, for reading the analog value and displaying on the screen, we have a small concept called the serial monitor. But this won't work with the real-time application, because in the real-time application, we will not be having anything like this. We won't attach our laptop to the product always. If such kind of things are there, no problem. In the shopping mall, if you go for any billing, there will be a billing software, and their printer is always attached to the their printer or anything. If you go to any kind of the metro station itself, there is a scanner, right? So scanner is a hardware device. So it is scanning by using the UV radiations. It is scanning the object whatever you are putting in that tray, in that rail. Okay, but that scanner data is lively displaying in the screen. It means it is a lively connected. In such cases it's okay, but in some cases, like whatever application we are doing is agricultural application, so we're going to display this device in the farmland. So nobody is going to put one particular laptop only for that, right? So in that cases it is going to definitely create a challenge. So we can't go with the we have a concept called as a serial monitor. I'll show you what it is first. So this is a serial dot begin. Now to display the see, when you are writing the value to the actuator, we no need to worry about whether it is what value we are writing, because we are only writing the value. It's a very simple. Let me give the example. I am giving the money to you. When I am giving the money to you, I already counted it and I'm giving to you. After it is coming to your hand, I no need to worry whether it is how much money is there in your hand now, because I already counted and I gave to you. But when you people are giving the money to me, I have to count it, right? Because I have to get a surety whether it is the whatever value I am getting is what is the number I am having with me. Same way, in case of writing the value, we no need to cross check. In case of reading the value, we have to cross check. Instead of cross check, we have to read what we are getting. And whenever we want to read what we are getting, we should have one display for that. We should have one display for that. That's the reason the software display is this one, serial monitor. So to start a serial monitor, we have to use a serial dot begin. 9600 is a baud rate. Serial dot begin 9600. And if I want to display anything, example, let me consider I would like to go with the concept of displaying the this particular PIR sensor reading. PIR sensor reading, that is the first input in our program, right? PIR sensor reading, that is the 7th pin. And as you know, already we declared one variable for that, PIR digital read PIR serial dot print ln yes. Now you observe, by default it is giving me 0 value, right? Whenever any object is moving, can you observe, it is giving me 1. If the object movement is stopped, after some time this mark will go back, it will vanish. Based on the, actually in reality they will be having some potentiometer to set this. So here internet speed is a little bit slow, that's the reason it's taking more time to go back to 0. Just wait for some time. Yeah, you can observe now it is going back to 0, right? So this is actually a virtual one. In reality it will go immediately, we have a setting for that. Okay, so this is the one where I am able to display its status by using the soft display. I'm able to display its status by using the soft display. You can observe, see. Okay, so this is what the concept called as a digital read followed by serial print. Digital read as well as a serial print. So now you understood, to start the serial communication, first we have to go for serial begin. So here it is. So syntax is, first thing is serial begin. Yeah, here serial begin followed by baud rate. Baud rate means rate at which communication happens. Okay, serial begin, baud rate, followed by, in order to write the value is nothing but print. As of whatever we are doing is a print. Serial dot print. Print means it will not go back, it will not take the reading to the next level. Data. Print ln. Next line. Same way we have one more called as a serial dot write. Three things are there. Okay, serial dot print, serial dot println, serial dot write. Same way we have in reading, serial dot read. Okay, to the holding variable. Same way we have serial dot read string, to read the entire string, incoming string. Okay, so this is a serial dot read, serial dot read string. So what we are doing here is, we are printing the value on the serial monitor from the digital read. Whatever status is there, according to that we are reading the value. Now example, sir, whenever somebody is coming in front of that particular I am keeping the land in the private mode or secured mode, and I have one room in the in my plant, that is a motor room. So somebody is trying to steal the motor, they are entering in the room now. So whenever they enter the room, I would like to create an alarm. Example, that is what the one application. So what you can do, PIR already you know, whenever somebody is moving in the covered area, it is going to give the high signal. So now what I will do, I'll use a if condition. If digital read equal to high. Okay, if the digital read is equal to high, I'd like to turn on the buzzer. Okay, turn on the buzzer until unless those people are going out of that. So now for buzzer, already it is same like a relay. Buzzer is same like a relay. So it is using pin number 6, that is buzzer pin. So digital write buzzer comma high delay 1000. Buzzer comma low. 1 second it will turn on, it will turn off. Again, if people are still moving, again it will turn on, turn off. Sir, I don't want it to make a blink, I want it to be constant, means you can bypass this. It will be always on until unless they go away from that area, it will be always on. So once they moved from there, what you can do, you can use a low signal. Okay, now you observe the screen. Yeah, see, now it is 0. That's the reason nothing is happening in the buzzer as well as with the buzzer as well as with the PIR. See, you can observe buzzer is making sound. That means it is giving the sound signal, right? Actually, it is making the sound. Since I turned off the speaker, that's the reason we are not able to hear. It is making the sound. So as soon they went out of that, so what happens? There will not be any movement in this particular area. There will not be any movement in this particular area. So since there is no movement in this particular area, we have to wait for some time. It will stop making the buzzer sound. Yes, you can observe. Now it stopped making the buzzer sound. So we did a one part of the automation, that is safety, safe lock for the this pump room, motor pump room, by using buzzer as well as the PIR. If you would like to go with a small buzzer, you can directly connect like this. Sir, we would like to go with a burglar alarm, like in colleges, in fire alarm station, they are going to use, right? That is a 230 volts high power device. Same way how you did a relay setup here, right? Same relay setup you have to do for even buzzer. If you would like to go for a burglar alarm, the bigger one. If you want to go for a smaller one, you can use like this. And even guys, not only relay, we also have a concept called as a MOSFETs, IGBTs, MOSFETs. These things also we can use for turning on the high power applications. Not only relay is making complete isolation, whereas MOSFET is a one, it is not an electromechanical switch, it is an electronic switch. Relay is an electromechanical switch, whereas MOSFET is an electronic switch. Okay, one part we did. So what I will do now, so this entire part I'll cut it from here. I'll create a function called as check safety status. So what happens now, whatever things you return, everything comes under one particular package, check safety status. Okay, then it was very easy, the alarm, like, because this is digital read and digital write. Since it is a digital read and digital write, we did it very clearly without any kind of issues. But when you go for the ultrasonic sensor, it is not straight away, guys. We have to use a concept called as a measurement. We have to go with some kind of concept called as a measuring the sound waves traveling the status. See guys, there are two round signal you can see here. One is transmitter and one more is receiver. What this transmitter is going to do, it is going to transmit the pulse towards the object, and what receiver is going to do, once the pulses are hit the object and come back, it is going to read it and it is going to identify the distance between the object and that reader sensor. So for that, first you have to make digital. Of course, many students will ask this question, sir, how do you remember so many code, something like that. See, even we learned it from the internet only. Since we practiced many times, we have that knowledge, like remembering the things. No need to worry, it's not compulsory to remember all these things. Yeah, you should understand the logical connection. Digital write, trip comma output. Digital write trigger comma output, delay in microsecond. We have to give a very small delay here. Yeah, sometime even I forgot this. See, seconds. 2 millisecond is enough. Sorry, yeah, 2 millisecond is enough. 2 microsecond. But I want to make sure that this is the right syntax. So just I'll cross check. Because the say like a delay microseconds, DELO, yes, S has to be small, M has to be capital, S has to be small. Even when you compile also, it will show you anyhow. Okay, so you can come to know what exactly the mistake, but just a cross checking, that's it. Then after that one, I'm going to turn on the trigger pin for 10 microsecond. 10 microsecond, I'll keep it on. After that one, I'll make it off. So this is a basic code. Okay, then int duration equal to 0 and distance equal to 0. So now duration equal to, there is a concept called as a pulse in. That means it is going to identify whenever there is a the input pulses are coming. Pulse in echo comma high. 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 After that one, we have to calculate the distance, we have to use a formula saying that duration multiplied by, if you want to calculate the distance in centimeter, duration multiplied by 0.034 into divided by 2. So what is the meaning of this one is, see, these are all the microwaves. Okay, so ultrasonic waves, sorry, not microwaves, ultrasonic waves. Due to that reason, what is happening, it is traveling at the speed of the light, normally air. Okay, speed of the air or light. So due to that reason, generally 3.4 kilometer per hour we are going to get, right? Same way, here like we are getting, we are converting that into the meter per second, sorry, centimeter per second. So by converting that into centimeter per second, we got this value. Okay. After multiplying that one with the duration multiplied by speed of the waves is going to give us the total distance traveled by the waves. And divide by 2. Why divide by 2? Because one side of travel is towards hitting the object. One more side of the travel is from reflection from the object, hitting the object and reflection from the object. Due to that reason, it is overall divide by 2. Distance equal to duration multiplied by 0.034 divided by 2. So this is what the total distance we are going to get. So what I want is, if the distance is less than 10 centimeter, or I'll consider 15 centimeter, then I'd like to open the gate. Already we have one particular function called as the open gate. I'm going to call this. Okay, so this is the one animation, one particular automation. So for opening the gate, okay, there is a small mistake. Delay microsecond, delay in microsecond, I gave wrong. It is a delay microsecond. Okay, oh, somewhere it is by default it is rotating. Check status. Okay, check status followed by, yeah, let me consider, let me do one thing. By default I'll keep this right 0, and also I would like to print what is the distance we're getting by default. Serial dot print ln print distance, serial dot print ln yeah, see, by default I'm getting the distance as 0. Just a minute, be online. Hello, just tell me. If it is giving the distance as 0, of course it will show always, it will always open the gate because it is less than 15, right? So now we have to find out what is the mistake here. That is 13 is a trigger pin. So I'll just cross check here where I connected 13. 13 is connected to trigger pin and echo, it's perfect. And hope this is properly powered up. Ground signal is also okay. And if I just keep it here, yeah, here I'm getting the centimeter properly, but it is showing 0 here. Duration pulse in echo comma high echo 12. So we made echo pin and trigger pin as a trigger as a output, echo as a input, and trigger output, trigger output, trigger output, pulse in echo comma high. Okay, let me do one thing. I'll display the duration also, so that one will come to know whether the waves are really traveling or not. So like this, you have to cross check whenever you have any issue with the program. You can cross check like this. Yes, I'm telling you. No, that spelling will not create an issue. It is just like a variable name. Spelling wise, there will not be an issue. It's just like a statement, that's it. Trigger. Oh, sorry. See, by mistake I mentioned trigger output. It should be trigger high. Sorry, first it has to be trigger low. I didn't triggered only. I just mentioned it as again high low output like that. That was a mistake. It's good you involved in the like solving the problem. Yeah, here I'm getting see 60 360. Okay, something else is coming, but not that much for. Okay, let me create a small delay. 1000. 47. Yeah, now we are getting the data, guys. So I mentioned below 15. So when I mentioned below 15, it has to open the gate. So let's see whether it's working or not. Below 15, it opened the gate. So 5 seconds it will be keep like 1 second it is going to keep in the same way, then it is going to close it. If it is still below 15, again it will open the gate, it will close. So whenever the person is already moved, so the value here will be more than 15, so it will stop opening the gate. Yes, it stopped, it is not opening the gate now. Again, when the sensor, like when the distance is less than 15, it is going to open the gate. This I'll make it as a function saying that void check gate status. Okay, check gate status. Yes, see now. So safety status, gate status, both we are able to do it. Yes, it's been a long class. We took this today. So up to this stage, everyone finish. Then let me know if any errors are